So in this video, we're going to talk about factoring with two terms. We call this the difference of two squares or the difference of squares, and you'll see why here in a second. Before we get going, go ahead and multiply these out and see if you notice a pattern. For example, I'll do the first one for you. X times x is x squared. X times negative 3 is negative 3x. 3 times x is positive 3x. And 3 times negative 3 is negative 9. Notice, negative 3x and positive 3x cancel each other out completely, leaving just x squared minus 9. Go ahead and finish the rest and see if you notice a pattern. So pause the video and try those. All right, so hopefully you've gone through these. I'm going to do these real quick. X times x is x squared minus 7x plus 7x and then minus 49. And that gives me these two middle ones cancel out. X squared minus 49. On this one, I get 25 m to the fourth minus 5m squared, and then plus 5m squared, and then minus 1, which simplifies to 25 m to the fourth minus 1 because these two cancel. So notice, this one had x's and 3's, and I ended with x squared and 9, and it was a minus. This one I had x's and 7's, and it ended up x squared minus 49. This one was 25 and 1. So what do you think this is going to be? Just take a guess without even having to work it out. A plus b times a minus b. Well, you end up doing a times a, which is a squared, and b times b, which is b squared, and it's minus because positive times negative is a minus, but the middle two cancel each other out. This always happens if your factors are the same except for one's plus and one's minus. So now we're going to think about going backwards. What if I gave you something like this and you wanted to create the two factors? Basically, all you need to do is split up the a squared, like square root it. That goes here. Whatever the square root of this is, that goes here. And then you make one factor positive and one factor negative, and that's how the middle ends up canceling out. We call this the difference of two squares because it is the difference of two perfect squares. For example, see how these are perfect squares? Like I could square root x squared, it would just be x, and I could square root 9, it would just be 3. And that's basically my factors, x plus 3, x minus 3. So again, it's the difference of two squares. So sometimes you'll hear it called the difference of squares, the difference of two squares. This is kind of the formula where a and b can be anything. Basically, you just square root the first thing, that goes in the front. Square root the second thing, that goes in the back. Make one plus, make one minus. For example, note that this is two terms. You still look for a GC at first, but there's not one here. And this is the difference of two perfect squares. This trick only works if it's the difference of two squares. So it's got to be subtraction, and they've got to be square rootable, basically. The square root of x squared is x. The square root of 9 is 3. And so this is actually the one we already looked at. So if I split this into two factors, they both need an x, they both need a 3, because x and 3, and then you just make one plus, make one minus, and that's it. This works because I get x squared, 3x and negative 3x cancel, and 3 times negative 3 is negative 9. It's got to be subtraction because when you make one plus and one minus, that's how you cancel out the middle term. But that means you're always going to get a negative at the end. So in order to do this, it's got to be subtraction. If not, you can't factor it. Let's try the next one. Again, I'm going to have two factors. Whatever goes in front is the square root of this. The square root of x squared is just x. The square root of 100 is 10. So put x in the front of both, put 10 in the back of both, and make one plus, make one minus. It doesn't matter which one, just make one plus, make one minus, and there we go, there's my two factors. Note that sometimes people try to square root the negative part, and that's not going to work out. First of all, because you can't square root a negative. It's an imaginary number, we'll get there, but you can't square root a negative. So just square root the number. Remember, the subtraction has to be there. That's just like part of it. That's how, when you have a plus and a minus and you multiply those together, it always gives you a negative. So, but you just square root the number part. On this one, again, this is the difference of two squares, things that square root evenly. The square root of 4x squared, we'll have to do this kind of separately. The square root of 4 is 2. The square root of x squared is x. And then here's a 1. 1 square roots evenly, it's just 1. Because 1 times 1 is 1. So in my two factors, I'll put 2x and 1, and make 1 plus, and make 1 minus. Sometimes people square root this stuff and they get excited that they remember to do that, and they'll be like, okay, so 2x minus 1 is the answer. Well, that's one of the factors, but you need both factors, a plus and a minus version. Let's try a few more. All right, on this one, this does square root. What's the square root of x to the 4th? Well, that would be x squared. You take the 4 and you cut it in half. Or x squared times x squared would be x to the 4th. Square root of 16 is 4. And so I'll fill those in my factors. X squared and 4. And then make 1 plus, make 1 minus. Here's the thing. This one actually keeps going. So this right here is the difference of two squares. And so we can keep factoring this one. You know, like with numbers, sometimes, like if I wanted to factor 30, that would split into 3 times 10, but then 10 splits into 2 times 5. So like you can just keep factoring. That happens here as well, and you want to keep factoring until you can't anymore. So x squared plus 4 doesn't break up anymore because it's a plus sign. If I tried to split this into like x plus 2 and x plus 2, it wouldn't work because x times x is x squared, that's good. 2 times 2 is 4, that's good. But I would get 2x and 2x, which is 4x, and I don't want it 4x. So that doesn't work. But this one will break up. Square root of x squared is x. The square root of 4 is 2. Make 1 plus, make 1 minus. There we go. So my final answer is this broken into those pieces, also times this. So my final answer is actually 3 factors. This times this times this gives me that original expression. Seems kind of crazy that all this multiplied together would give me just 2 terms, but it does work out that way. All right, let's try the next one. This one's got 2 variables, but that's okay, we just do it the same way. It's still just the difference of 2 perfect squares, because the square root of 9x squared is 3x. The square root of 25y squared is 5y. And so then fill in your 2 factors with those things, 3x and 5y. 3x goes in front, 5y goes in the back, make 1 plus, make 1 minus. There we go. Neither of those keep factoring because I can't square root either of those. On this next one, it seems like it's not factorable because it is the difference, but I can't square root 3. But there's a GCF on this one, so you want to factor out the GCF first. I can divide both of those by a 3 right off the bat, which will leave x squared minus 1. And now, as we always do with the GCF, just leave it in front and pretty much just ignore it till the end. Now I'm just going to deal with this, x squared minus 1. The square root of x squared is x. The square root of 1 is 1. So the two factors are x plus 1 and x minus 1, because x and 1. Don't forget about the GCF, just leave it in front. So the 3 stays in front, and that's my final answer. Just a few more examples here. All right, on this one, any even power will square root evenly. So like the square root of x to the 4th is x squared. The square root of y to the 4th is y squared. So this splits into x squared and y squared, and another x squared and y squared. Make one plus, make one minus. This is another one where I can keep going. So this doesn't. It's not the difference of two squares, it's the sum of two squares, so that one won't keep going. But this one will. This one can split into two additional factors, because the square root of x squared is x. The square root of y squared is y. Make one plus, make one minus. There we go. Don't forget that this was also a factor, so I'm going to put it as well. It can go in the back or the front, it doesn't matter. But all three of these multiply together to give me this. They're all three factors. All right, on the next one, this is the difference, but it's not two squares. I can square root this, but I can't square root 2. So that one is not factorable. When a number doesn't factor, like for example 5, 5 has no factors besides just 1 and 5. Same with 7 and 3 and 11 and 13. These numbers, we call them prime because they don't have any factors except for 1 and themselves. Same thing here. The only thing I can factor out would be a 1, and that's not very exciting. So just like with numbers, we call these expressions prime, meaning it doesn't factor. I mean, technically on this one, if you really wanted to, you could have split it into x plus square root of 2 and x minus square root of 2, because that's the square root of 2 anyway, but I wouldn't bother getting into radicals. Same thing with this one. It is the difference, but it's not of two squares. You can square root this, but you can't square root 7. And there's no GCF or anything on either of these. So once again, this is prime, meaning it does not factor. And the last one, it's really tempting to be like, well, square root of x squared is x, and the square root of 100 is 10, and so there's my factors. Except for this doesn't work, because that's a plus. Anytime it's a plus, you're not going to be able to factor it. It's gotta be subtraction, the difference. Because it just doesn't work out. Like, if I make one plus and make one minus, 10 times negative 10 is always gonna be a negative. And that's the only way to get 10x and negative 10x to cancel, so it's gotta be a plus and a minus. You can't have plus and plus, because then I would have 10x plus another 10x, which would be 20x. So that doesn't work. Once again, this is prime. It does not factor. It is not the difference of two squares. It's the sum of two squares. All right.